We're going to take a look at the 2019 free response questions 1 through 3. Problems 1 and 2 are with a calculator, and problem number 3 is without a calculator. So let's look at the prompt. People enter a line for an escalator at a rate. So the first thing we want to pay attention to is that they're giving us a rate modeled by the function r, which happens to be a piecewise function. So this is going to be our on, or what we would probably call our in rate. R of t is measured in people per second, and t is measured in seconds. As people get on the escalator, they exit. So here comes probably the out rate. They exit the line at a constant rate. So this is going to be our out rate. 0.7 person per second. There are 20 people in the line at time t equal to 0, so we have an initial condition. All right, so let's take a look at what they're asking us to do. I don't think this one's going to be too challenging, but I do have my calculator to show you some things on the calculator. Question A. How many people enter the line for the escalator during the time interval from 0 to 300? So it's a how many question, so we know that since we have a rate, we're going to integrate. And this is only wanting the people that are entering the line. So let's take a look at my work, and then I'll show you the official scoring rubric. So in 1A, I do not use the initial condition in this prompt because they want to know how many people entered the line from 0 to 300. So that's not including the people that were already in line. So in my work, I'm going to accumulate from 0 to 300 of R of t. I'm going to do that with my calculator and get 270 people. Now when you put that into your calculator, just be careful with the parentheses. The calculator, it's nice to be able to use a calculator, but that can also mess you up if you type it incorrectly. So we've got parentheses, x divided by 100, and that's going to be cubed. And that's multiplied by, and this one's going to be a little tricky, make sure you get all your parentheses in there correctly, 1 minus parenthesis x divided by 300, close the parenthesis. In other words, you want that fraction in a parenthesis, and that's going to be raised to the 7th power. And then I'm going to put in for y number 2, I'm going to go ahead and put in my out rate of 0.7 because I'll probably need that at some point. I'll turn it off for question A. And I'm going to put in y equal to 0 so that I can officially graph the x-axis if needed. So now I'm going to go to the home screen, and I'm going to do, let's clear that out, Math 9. Use however your calculator operates. The function that I want to accumulate is y1 in terms of x from 0 to 300, and I get 270. So again, this is the classic in rate out rate problem. All right, let's take a look at letter B. In letter B, during the time interval from 0 to 300, there are always people in line for the escalator. How many? Well, here's another how many question, so likely going to accumulate, are in line at t equal to 300. So this is talking about the people in the line the entire time from 0 to 300. So now we want to find out how many people are still in line at t equal to 300. So in this case, we are going to use the initial condition of 20 people because there were 20 people in line to begin with. We're going to accumulate the people that entered the line, and we're going to subtract the people who exit the line. So we already did that integral. Now we're going to have to do this integral with our calculator. So you need to write up the integral. You don't necessarily have to recalculate this 270. You can bring that over in your answer. So it's 20 plus 270. And then all you've got to do is, when you're going to integrate, you're going to go back to Math 9. And this is, the function is y number 2, comma, in terms of x, comma, from 0, comma, to 300, and that gives you 210. So if you take the 20 plus the 270 minus the 210, remember the 270 are the people that got into the line, you get the 80 people that we were looking to accumulate. All right, so let's look at the scoring guide for just a moment on question A and B so that you can attempt to score yourself. So in question A, you are going to get 1 point for the correct integral and 1 point for the correct answer. You have to show that integral. In letter B, there are 2 points allotted. One is for considering the outrate, and the reason that they're saying that is because the 20 people is the initial condition. If you don't have the 20 people, that's going to come off of your answer point. You already accumulated the people getting in line in A, so what they're really trying to figure out here with the consider the outrate is, do you understand that you're going to have to accumulate the people that are getting off of the escalator? So those are your 2 points for 1A and B. Let's take a look at part C. In part C, they ask us for t is greater than 300. So remember, we have this piecewise function up here, and this is for greater than 300. What is the first time there are no people in line for the escalator? All right, so let's take a look at my work in part C. Now this time, last time we went to 300, now we're going to an unknown time, and we've talked about this before in class. So we're still going to use the same equation that we had before, same work. So we had 20 people in line. We accumulated only, people were getting in line only from 0 to 300 as indicated by the prompt. But they continue to get off the escalator, and we don't know what time when there will be no people in line. We don't know when this thing is going to empty out. So there's our unknown time. There's the outrate, and we want that to equal to 0. And so we had already calculated from before. There's our 20 initial people of 20. There's the 270 that we calculated in part A. And then when we integrate 0.7, we get 0.7t, and we're going to set that equal to 0. So now all I have to do is to type that, add 20 plus 270, which is 290. So I have 2 and y equal 2. I'm going to turn off y1. So I'm going to have 290, whoops, minus 0.7x. And I'm going to figure out where that intersects. Now this is going to be a number that's way out there, so we're going to have to adjust the window. So if you do a zoom 6 window, by no means is that going to show in the window. You have to think about we're going past 300. All right, so you can stop the graph by pressing the on button. Open the window past 300. I'm going to go x max of 500, and I'm going to count by 25s or 50s. That doesn't really matter. And then I'm going to take a look at the graph, and I see that there's an intersection point there. So I'm going to use my calculator. Second calc 5. Enter, enter, enter. And I get the 414.286, which is what they were looking for. And that's when there'll be no people in the line. So for that question in part C, let's look at the scoring rubric. You simply get 1 point for the answer. So for that one, either you get it or you don't get it. Finally, part D. In part D, they're asking us again to go to the good old EVT. So at what time is the number of people in line a minimum? So we're looking at EVT. I can continue to remind you that we have to consider the endpoints. It has to be in the argument and the critical numbers. To the nearest whole number, find the number of people in line at this time. So not only are we going to have to say when they're at a minimum, we're going to have to find how many people there are. So in this case, to find the critical numbers, as you know, we're going to take our in rate minus our out rate, and we're going to set it equal to 0, and this is going to give me any critical numbers. And that's going to come directly off of your calculator. So in my calculator, I have the in rate in Y1, I have the out rate in Y2. I'm going to turn off Y4, or I could even get rid of it because I don't think I'm going to be using it again. But in Y number 5, and you have to keep track of this, I'm going to have Y1 minus, I thought I was going to, Y1 minus Y2 and make sure those are the functions that I want. And I'm going to just hit graph because remember my window was already open out to 500. So I see a point of intersection here, point of intersection here. Okay, so then we're going to do a second calc, 5. And I'm going to move it over here. Enter, enter, enter. So there's the 33.013. Do it again for the other point of intersection. And that's 166.574. Now, we're looking for a minimum, so we notice that the first derivative changes from negative to positive here, so local minimum. From positive to negative here, that's going to be a local maximum. So you could make a statement in your work that you're not considering the local maximum because it can't be the absolute minimum. So then I'm going to make a table. And I know at 0, that's one endpoint, there were 20 people. And we calculated in part B that at 300 there are 80 people. So now to calculate the number of people at 33.013, and I should have stored that number. So just to remind you, I know you know how to do that, but I'm going to do it anyway. So second calc 5, let me go back to that point of intersection, enter, enter, enter. And so I'm going to second quit, store, alpha A, and now that 33.013 is stored in my calculator. Now if you look back up here, I already have the integral that I did with the 300. Oh no, that was for the out rate. So yeah, so now for the integral, I'm going to do 20 plus and math 9. So I want the n rate. I want to accumulate the people getting on the escalator. So that's going to be y1 in terms of x from 0 to alpha A. I didn't put a comma. And then minus, I want the people getting off of the escalator. So math 9. Y2 is where my out rate is, comma x, comma 0, comma alpha A, close. And I get 3.0803, sorry. And so I can declare that to be the minimum. Now, my work, I did not declare that the function for the people getting on the escalator is continuous on the closed interval, which I actually should have done. So let's look at the scoring guide and see how the points are awarded. So you get 1 point for setting the in rate minus the out rate equal to 0. And you have to show that. In some way, shape, or form, you have to show that you're setting the in rate minus out rate equal to 0. You get 1 point for picking up the 33.013. Notice there's not a point for not picking up the 166.574. 1 point for the answers, and that's looking at the 20, the 3.803, and the 80. You can include the 166.574. You can get the number of people there and include it if you want to and rule it out that way, or you could rule it out the way I stated earlier. And then one answer for your justification, and in this case, your table is your justification. It's the smallest y value or the smallest number of people for those time periods. Question number 2. Question number 2 is our classic particle problem, or position or movement problem. So very likely you're going to have some sort of position or particle problem on your test. Let's read the prompt. A particle moves along the x-axis. So again, it's like the 2019. We have a particle that's simply going back and forth along the x-axis. And the velocity is given to be this function right here, which is not really scary because we have a calculator. The position at x equal to -5 is 0. So we have an initial position of -5, 0. And we'll see how that comes into play, or if it comes into play. It could be extraneous information. Find the acceleration of the particle at t equal to 3, and this we're definitely going to use a calculator to do that. Find the position of the particle at t equal to 3, and that's when we're going to come and bring that initial position in. Position needs position. Lastly, we're going to evaluate this integral and this integral and interpret the meaning, which is actually pretty easy. Finally, in letter D, they introduce a second particle with an additional velocity. At what time are the two particles moving the same velocity? So really not too bad, but let's take a look and see what happens. So let me go into my calculator and get rid of all of the functions that I had there before. I'm going to keep the y equal to 0 in there. And in this case, y1, so be really careful. We're going to need to put parentheses around the numerator and parentheses around the denominator. So I have parentheses, make sure this is in the window, 10, sine. Of course, make sure you are always in radian mode for calculus. 0.4 x squared. Make sure you put the square on the x, not on the parenthesis, and close that parenthesis for the numerator. Divided by parenthesis for the denominator, x squared minus x plus 3, close that parenthesis. Okay, so I have the function in there. I don't think I'm going to put anything else in there right now. So for part A, that's a great calculator problem, easy calculator problem, and easy points. Find the acceleration of the particle at t equal to 3. So we know that the acceleration of the particle, so what I'm going to show in my paper is that I know that acceleration is the derivative of velocity. That's pretty much my setup. That's all I have to show. Now I'm going to go straight to the calculator. I'm going to go to the home screen, clear out all that stuff, and I'm going to make the calculator find the derivative, which is math 8. It's the derivative of the function that I have in y1. Call it up however your calculator does it. The function is in terms of x, and I'm going to do it at a specific value of x of 3. And then I'm going to record to 3 decimal places, rounded or truncated, the number that the calculator gives me. Easy stuff. B, find the position of the particle at t equal to 3. So at t equal to 3, we already talked about the fact that there was an initial condition. Well, not at t equal to 3, but to find the position, you need position. So this is the initial position of -5. Accumulate the area under v of t from 0 to 3. So back to the calculator. I like to have a clean home screen, so I'm going to get rid of that. -5 plus math 9. The function, whoops, clear that out. -5 plus math 9. The function in this case for my calculator is y1 in terms of x from 0 to 3. And there is your -1.760. You do not have to include units. In fact, I don't think they gave you any units in this problem. Letter C. Evaluate two integrals. So those are literally coming off of your calculator. So we're going to do math 9 again. We're going to call up the function, which is in y1 in terms of x from 0 to 3.5. And we're going to record that number, either rounded or truncated. Now, I don't know how many of you are aware of this, but if you want to recall this, for example, this statement right here, all I really need to do now is put absolute values around y1, and some calculators make that easier than others. But to do that, if you press second enter, it will bring back the last thing that you just typed. And so now I can come back in here, or you can retype the whole thing, and to insert, right above the delete button, there's an insert written in blue, and there's a second here. So I'm going to second insert, and then I'm going to go to math, arrow over to num, and the first thing I see is absolute value. I'm going to go behind and close that parenthesis with, again, a second insert, parenthesis, enter. And now when it's done, I will have record the number of 3.737. Now we have to interpret what those mean, but you know exactly what those things mean. So in letter C, we're looking at the change in position of the particle. So you could write change in position, or you could write displacement of the particle from 0 to 3.5. The absolute value around the function, not around the integral, guarantees that we will pick up the total distance traveled by the particle from 0 to 3.5. And we've done a lot of work on interpreting, so I know you did a great job with that. All right, letter D. A second particle moves, let me bring that back. A second particle moves along the x-axis with along the x-axis with position. So this is a position function. At what time are the two particles moving with the same velocity? Of course, we know that the word same means equal. So we're literally setting the velocities equal to each other, but remember, this was a position function. So we need the velocity by taking the derivative, simple power rule, 2t minus 1 is the velocity function for the second particle. So we're going to take the original velocity function that we had. So you can see down here in my work, make sure that's in the window. So this was the velocity that was given, and this is the velocity of particle number 2 that I found by the power rule. I set them equal to each other. So I already have this function in y1. I'll put this into whatever I don't have something into. I think I don't have anything in y2. And I'm going to determine where they intersect. You could change the window from where we had it before, because we had it out to like 500, but you probably don't have to. And they intersect at 1.571. So this is really not that bad of a problem. You really have to persevere. You have to read, but you definitely can earn a lot of points on this one. So let's take a look at the point distribution. So go back and look at your work again. In letter A, we're going to show what we're doing, v prime of 3, and we simply get 1 point for getting the answer correct. But please don't have a bald answer and just record the number. Just tell us what you are doing, either a of 3 or v prime of 3 or a of 3 equal v prime of 3. In letter B, we have to see that you wrote a definite integral from 0 to 3. So you're going to get 1 point even if you don't have the initial condition. Then we need to see the initial condition, and don't get confused by the scoring guide. Remember, I didn't write x of 0 and x of 3 and all that kind of stuff. I showed you my work first to show you what acceptable work looks like. And then finally, you're going to get 1 point for the answer. In letter C, you're getting 1 point for the answers, meaning they both have to be correct in order to get that point. And then you're going to get 1 point for the correct interpretation of the position and 1 point for the correct interpretation of the distance traveled. In letter D, you get 1 point for literally setting the two velocities equal to each other. So we have to see it, no bald answers. And then the last point is for getting the answer itself. So that's problem number 2. Problem number 3, it's time to put the calculator away because there's no calculator on problem number 3, and this is your classic, I like to call it your geometry problem, because you're going to definitely be doing some geometry to accumulate some area, I'm quite sure. So let's take a look at the prompt. The graph of the continuous function, important to note, we have a continuous function, g, the derivative of f, very important. Always write down when you see something like that, that f prime equals to g. Write it down on your paper so that your reader can see it. It's best to put it within the body of your work, but put it somewhere. F prime equal to g. That's connection point, and we may need to see it to get that connection point. The function g, the one that's graphed, is a piecewise linear, and it's piecewise linear from here's linear, 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 and then for the section from 3 to 6, that is the equation of a quadratic or the equation of a parabola. Letter A, f of 1 equals 3, initial condition. Find f of negative 5. We've done that recently, so hopefully you find that to be pretty easy. Then we're going to evaluate from 1 to 6 g of x, so geometry, geometry, geometry. For the interval from -5 to 6, what open intervals, if any, is f both increasing and concave up? That's the all about me sheet. Definitely spend a lot of time making sure you know the information on the all about me sheet. And then D, find the x-coordinate of each point of inflection on the graph. All about me sheet. So notice we've got two things that are coming directly from the all about me sheet. All right, let's go back to 1. If f of 1, initial condition, is 3, what is the value of f of -5? So we're going to take the initial condition of 3. We're going to add to it the net area accumulated from 1 to -5. Now notice these bounds are out of order. You know what that means. We're going to have to negate the areas. So we're going to accumulate the area. Let's come back up here and look at the graph. We already have 3 units of area. We're going to start at 1, so you see the triangle, and that is above the x-axis, and normally we would count that area as positive, but we're going in the opposite direction, so we're going to have 1/2 of 2 times 1, and 2 times 1 is 2, so in my work you can see the 3 is the initial condition, minus, because I'm going the opposite direction, 1/2 base times height, so that takes care of the first region. Then for the second region, be really careful, because I noticed recently that some of you were accumulating the wrong regions. It has to include the x-axis. So this is the next region that we're looking at, not this region in here. There's no area there. So this is a triangle, 1/2 base times height. So it is 3 by 1. So, and since this region is below the x-axis and we're going in the opposite direction, notice in my work I'm going to add 1/2 of base times height. So that's where I got those numbers. And then in the last region, we have a square from here to here. That is 3 by 3. Oops, sorry, I didn't let you see the square. I'm sorry. 3 by 3. And the area of that 3 by 3 is shown in my work here. Understand with 100% certainty, this can be left. Remember, we're not using a calculator. That can be your final answer, and you will get full credit. You don't have to multiply anything together. You don't have to simplify anything. I did, but you do not have to. This is not a hint that I'm trying to say you should simplify. In fact, I'm telling you, you should not simplify. This would be a full credit answer. All right, let's take a look at B. We're doing the same thing, but we're going from 1 to 6. And now we're going in the positive direction. So, since we have a parabola, let's take a look back up here at the graph. Since this region is a parabola, we can go from 1 to 3 using geometry. So notice what I did with my integral down here. I said 1 to 3 of g of x dx plus, then I changed the integral 3 to 6, and now I have that quadratic function that I'm going to have to integrate. So I'm going to find the area from 1 to 3, and the area from 1 to 3 can be accumulated by 2 triangles and a square, or you can do the area of a trapezoid, whichever. No, that's not. Oh, sorry. I almost messed up. Yeah, we got to break it right there. So it's a triangle, and we already knew that the area of that was going to be 1/2. And then this is going to be 2 by 2 for an area of 4. And in fact, we're going 1 to 3. Yeah, get my head in the game here. That makes it even easier. 1 to 3. So we're just accumulating the area of that square, which is a 2 by 2. So that is where I got 2 by 2, which is 4. Is that in the window? Barely. Okay, then to find the antiderivative of this function, I squared the binomial and distributed the 2. Be careful with squaring the binomial. You do get a trinomial, x minus 4 times x minus 4, and then multiply by 2. Then I found the antiderivative, excuse me, here. And then notice what I did. I substituted the upper bound with no simplification. I substituted the lower bound with no simplification. Do not simplify without a calculator. Leave your answer exactly like that and you will get full credit because it is correct. Letter C. From -5 to 6, on what open intervals, if any, is f both increasing? Now remember we have the graph of f prime, which is g, so increasing means that f prime, which is g, is greater than 0, is positive. And for the second derivative, which we don't have, but we do have the first derivative, so if the second derivative of if the first derivative of f is increasing, then the second derivative is positive. So we can use, and that's from the All About Me sheet, so we can use this graph to get both pieces of information. So if I look at my graph, which is kind of marked up, but the graph of f prime is positive in this zone right here. So now I know that region meets the criteria of f increasing. Now I need to see where f prime increases. And f prime increases here. And we're going to 6, I believe. Let me check myself. Yep. And here. Okay. So f is both increasing and concave up on 0 to 1 and 4 to 6 because the first derivative, or you could say g, is positive and increasing on these intervals. So you could say f prime or g. You can close on 0 and you can close on 6 if you want to, but we really don't penalize for the opens and closes on these kinds of questions very much. All right, one more and we'll be done with this one. Find the x-coordinate of each, bring it back down. Find the x-coordinate of each point of inflection. So from the All About Me sheet, All About Me, I can't say it enough, All About Me sheet, wherever f prime, first derivative, has local max and mins, that is where the second derivative, or f, that's where f has points of inflection. Now this one's a little bit tricky and I wish my graph was clean. I don't think I have another copy of this nearby, so I'll try to walk you through. I'm going to highlight in green. So this one's tricky because you're going to want to think that some of these are local max and local mins, but like right here, sorry, I'm bumping the thing. Okay, give me 1 second. Okay. The graph of g of f prime is constant in that area. So even though the graph starts to increase here, that's not a local anything because it was just constant to increase. It wasn't increase to decrease or decrease to increase. And then in the next region, it goes constant again, and then it increases, and then it goes constant again, and then it decreases to increase. So the only place where there is a point of inflection, or that g f prime has a local anything, is at 4. The other values of x are not local maxes or local minimums. So f has a point of inflection. Let me get that in the window for you. F has a point of inflection at x equal to 4 because f prime has a local minimum at that value. Right, this is my work. Now let's look at the scoring rubric and we will be done. Go back and take your work and try to score yourself as best you can. In letter A, we're giving 1 point for the integral, and the integral is not necessarily needing the initial condition. And then 1 point for the answer, and it may be unclean. So if you didn't include your initial condition, it would come off of the answer point. Letter B,